So next we have our very own Eugen. So I will let him take the stage. But before that, what he will be talking about is how to pick your LLM stack. What goes into an LLM application? At least an LLM, an embedding model, a vector database, some data processing tools, and maybe a couple other things. Today, we have been hearing from the people who have been driving these innovations forward, and we'll hear more after Eugen's talk. But right now, he will be introducing a framework for how to think about these different tools coming together and covering some of the existing options that are available to us.
Cool. Thank you for introducing me, Megan. It saves me from having to introduce myself. So for those of you who have been following along with this series, you know that we've been doing a lot of work with getting the LLM stack introduced to people, as well as talking about what goes into it and what makes the LLM stack and what is so important about this. So one of the reasons why I want to talk to you today about picking an LLM stack and thinking about the LLM stack and giving you this framework to think about it is because, well, let me get to it. There are hundreds of tools, and there's not really an easy way to figure out how to pick these different tools and how to think about these different tools. So there's hundreds of tools in the LLM stack. And in this specific market map, if you scan this QR code, it'll take you to a Medium article. In this specific market map, you will see that there are at least 100 tools in here. And this doesn't even cover the entire landscape, right? There's new tools that are popping up every day, like every week. Yesterday, I was just talking to someone who has just started another AI quality tool. So there's just tons of different tools that are popping up every day, every week, and I try to keep this as up to date as possible. I'd also like this to be an interactive presentation, so I'm going to ask some questions as I kind of go about this presentation, and I would love if you would respond in the comments and let me know kind of what you think. So the first thing we're going to talk about in this set of presentations is the LLMs. So if you recognize any of these companies, I would love to know which of these companies, which of these logos you recognize as I talk about this slide. Okay, so if you recognize any of these logos, drop them in the chat. We just want to see which one of these logos are recognized. So the first thing to know about LLMs is that here I have 12 logos for the LLMs in this stack. And these logos are definitely not a exhaustive list of the LLMs that people are working on. These are just some of the most popular ones that people know of, or some of the ones that I've been able to encounter during this time, right? So I see that some of you guys are participating, which is great. So some people have seen, Anthropic, of course, ChatGPT. You guys are calling OpenAI ChatGPT, which I guess is fair enough since that is their most popular product. That's their most well-known tool, right? So OpenAI is down here, and then you can see Anthropic as well up there. Mistral is up there. So Mistral is like the OpenAI of Europe. Then there's Symbol next to Mistral. They do conversational AI. So all of these things kind of do something different. Next to Symbol, so Symbol is this like black, I don't know, this polygon looking thing. Next to that is RC, which does, maybe it's Archie, I actually don't know how to pronounce it. They do small language models. And then next to that is Noose Research. So they're a research lab based out of SF, and they do a bunch of research on how you can fine tune open source LLMs and things like that. Some of these other models are out there like Gemini. We heard Frank talk about Gemini earlier today. Gemini has this huge 1.5 million context window that was Google's kind of play to be unique in this space, right? Gemini has probably the longest context window out of any of these. And then under Anthropic, we've got Llama. In this case, I have Llama 2, but really we're on Llama 3 now. And if you caught my talk with Mark Huang from Gradient earlier last month, then you'll know that you can actually fine tune open source models to have longer context windows, and that Gradient was able to fine tune Llama 3 to become a 1 million plus context window model. So I see some of these other people here are, recognizing Gemini, someone who's not called ChatGPT, not called OpenAI ChatGPT. Someone else is here is talking about Mistral, right? Mistral is out of France. So these are just some of the models that are available. And all of these companies try to do something a little bit different around the LLMs. And maybe this is going to be a hot take, but most LLMs, of course, I will say OpenAI is the leader in terms of LLM functionality, LLM quality as of right now. But we don't know how long that's really gonna last, gonna be, right? LLM innovation and speed of development is just something that is going forward really quickly, and it's great that so many of these people are working on driving this forward. And I really hope to see that the open source side of things starts to take a leap forward in terms of the technology that's used and the technology that is available openly, publicly, right? And so some of these companies that are doing the open source stuff are like, Llama from Meta and Mistral and some of these other ones as well. And you'll see that I'll be talking about Hugging Face later. Hugging Face has a bunch as well. Okay, so other than LLMs, the next step or the next set of tools that are part of this would be the LLM providers. So if you recognize any of these, drop me a comment in the chat and let me know if you recognize any of the LLM providers. So you should at least recognize one of them because we had someone from Fireworks, which is the little purple logo. We had someone from Fireworks come and talk just recently. So why is there even a set of companies that are built on LLM providers? Like, why are there a set of companies that are just built to provide you LLMs? Now, of course, not all these if you talk to these companies, they will say they do more than provide you LLMs, which is true. But I will say that one of the most integral parts of what they do is they provide LLMs. And one of the reasons why this is important is because LLMs, open source LLMs even, are difficult to run right now, right? They're not actually something that you can just pick up and put on any laptop, on any old computer and get it to run, right? So NVIDIA, and you'll see NVIDIA's logo later on, NVIDIA is one of the most valuable companies in the world now. And one of the reasons for that is because they provide GPUs, and you need GPUs and CPUs to run LLMs. LLMs are huge, and they're very, very compute intensive. They're very, very computationally expensive. And because of this, it's not easy for everyone to be able to access and deploy and use LLMs locally. So there's a whole slew of companies that exist to provide LLMs. So there's Martian up in the first corner over here. They provide LLMs. Fireworks provides LLMs, right? So Arvind was just talking earlier about how Fireworks has recently released the ability to natively do function calling with Fireworks, right? So function calling is a piece of LLMs that allow you to build AI agents. And it's not simple. It's not something that you can just pick up any LLM and have it do, right? OpenAI kind of does it out of the box with their API. That's something that they do that they really drove forward, right? So AI agents has been around for a while, but they haven't really worked super well, and they haven't really worked effectively or efficiently or even dependably in production. And so some of these companies are now pushing this out, right? Fireworks, OctoAI. Someone recognizes OctoAI. That's great. So OctoAI is based here in Seattle. So for those of you who don't know, I'm in Seattle. OctoAI is based in Seattle. They have an event tonight, so I'm going to go out and talk to the OctoAI people today. The AI event scene in Seattle is, alive and well. I hope that it gets as fun and as hype as the SF scene, but we'll see. That's part of my personal goals. Other than, Octo AI, there's, Amazon Bedrock, as Andre noted. AWS Bedrock, Amazon Bedrock. I don't know. As far as I know, so this is more of an opinion take than anything else. But as far as I know, there's not a lot of usage of Bedrock, and it's probably not great. Even internally at Amazon, I've heard that it is not very popular. But we'll see, because technology evolves very fast, and whatever. And then there's Together AI. So Together AI, unfortunately, could not make it today. They were originally slotted to speak today, but they had a couple of speakers who were both out. So it was really unfortunate that Together AI was unable to make it. We could not hear about what makes their LLM special, their LLMs different. Below Together AI is a picture of a llama. This is really cute. I just put this in here because I wanted a cute picture of a llama. No, I'm kidding. So this is Ollama. Ollama is a tool that is used to run LLMs locally. They're a software company based out of SF. They've also hosted a lot of events. They hosted a lot of events last year. And I don't know if it was their event or if it was a Hugging Face event, but there was an event last year where they actually brought in like real llamas to the event. And I heard it was kind of a shit show, but it was kind of cool. Like, I would have loved to go to an event where I could like interact with a real llama, right? So also, like, for those of you who have asked this question about like, llamas, why are llamas so popular for these kinds of tools? Well, LLM, right? So there's an A. If you put an A between the second L and the after the M, you get llama. So that's why llamas are so popular. Okay, next together is a company called Gradient. So earlier I mentioned that I talked with Mark Huang from Gradient, and they were the company that fine-tuned Llama 3 from a 8K context window into the 1 million, 4 million context window. So Gradient is providing not just these fine-tuned LLMs, they're actually closed source. They don't really offer open source LLMs for you to easily use, but they also build RAG applications, as we heard earlier from Frank, from Fabiana, from so many people about the popularity of RAG applications. Gradient also builds RAG tools. They also build AI agent tools. There's a ton of different things they do, but providing LLMs is one of their core competencies as well. Below Gradient, we've got a company called LM Studio. LM Studio is a lot like Ollama. What they do is they provide you a way to run LLMs on your local machine. And LM Studio is powered by this thing called Llama CPP, which is a tool that basically makes it so that you can run LLMs on your machine. Okay, so I see a question here about Cohere. You're right. So I'm missing Cohere from this list. To be honest, it's just because I don't really know a lot about Cohere. I actually met with some of the Cohere people at an event last year, and it seems they're doing a lot of different work in the space, providing a lot of different technologies. I'm actually just not very sure how to classify Cohere as a company. So that's part of the reason why they're not on here. And I also see something about Zillis. Zillis is not on here either because Zillis is not an LLM provider, but they will be in the vector database section. Okay, so we've gone through kind of the LLM providers. These are the companies that are just giving you ways to access LLMs, not just, they are giving you ways to access LLMs and some other things as well. Next, we'll look at embedding models. So someone asked about embedding models earlier. Oh, yes, someone said Ollama. That's the picture of the cute llama that I had on the last slide. So embedding models are incredibly important to the way that you build applications because they determine the context that the semantic similarity is done in, right? So earlier, someone asked a question about embedding models. What are embedding models? Really, in my opinion, embedding models are just any model that you can use to make an embedding. And an embedding is, oh, I totally forgot to say at the beginning of the slide, right? So if you recognize any of these companies, if you recognize any of these logos, drop me a comment below so I know who knows about these things and which one of these things are well known. I think there's 3 logos on this slide that I feel like everyone should get, and the rest of them, maybe not. But anyway, so embedding models are incredibly important because they determine the context in which the relevance of your unstructured data, of your text, of your images, videos, audio is determined. And so earlier, Frank told us about a really interesting embedding model that does 6 types of modalities. I don't have that embedding model on here. I don't have that company on here, but next time I will. It's great to learn about these kind of new things. I even learn about new things in these talks, which is great. But embedding models, the way that they work is essentially you have any deep learning model and you cut off the last layer of that model and you take the output of the second to last layer, and that is your first, and that is your embedding. And embedding is just a long set of vectors, it's just a long vector, a long set of numbers. And why do you cut off the last layer? Why do you just take the output from the second to last layer? It's because as you run data through a model, the model learns new things about that data with each layer that you run. And when you get to the last layer, most models, not all models, right? Generative models are a little bit different. Most models, and even generative models, kind of work this way. So what they do is they predict what the most likely outcome is. So generative models just doing this on a large scale. They're predicting the next few outcomes, the next few tokens, whatever. And so that's what models do. And because models work that way, if you take the second to last layer, then that layer has all of the semantic information that model has, all the information that model has about the input data, all in that second to last layer before it makes a prediction. And that's how it makes the prediction, right? So that's what an embedding is. And this is how we compare unstructured data. We compare the embeddings. We compare the quantitative values of the semantic meaning of these different models, okay? So that's what these embedding models are. And these are just some of the embedding models that are on here. So we have Voyage AI, that comes out from a lab in Stanford. They have a lot of great models that are all hosted on Hugging Face, the yellow face with the 2 hands next to it, which really is kind of a strange name for an emoji, but Hugging Face is an emoji as well as the logo for the actual company, Hugging Face. Next to that is the Beijing Academy of AI. So they've also produced, oh man, I forgot what embedding model they produced. I think it's GTE large or maybe BGE. Maybe it's BGE. There's these two like very popular, and the other one is produced by Alibaba NLP, which is right below them. There's these two very popular embedding models that are, one is GTE and one is BGE. And I don't really know what either of these stand for, but they're both very popular and they both do very well on the MTAB leaderboards. The other two companies on here are Mixed Bread, which is the M, which is like from a research lab / university in Berlin. And then the other one is Gina, which is a global company that has people in SF, Berlin, Beijing, all over the world. So these are the embedding models. These are incredibly important, remember, because embedding models determine the context in which the semantic similarity of your inputs of your unstructured data is determined. So next up, we've got infrastructure tools. So these are tools that basically allow you to build LLM applications, right? Like earlier I was saying, one of the hardest parts about LLMs is, and why these companies exist that are just basically LLM providers, is because it's hard to build these. It's hard to access these. It's hard to get ways to effectively use these tools. Despite the fact that it's such an advanced, popular technology, it is not something that is very easily accessible. So, of course, I alluded to the idea that NVIDIA would be on the infrastructure tool map, and it is, right? So NVIDIA is up there, and NVIDIA is not the only tool, right? NVIDIA provides the GPUs. They do a lot of things, and later on today, we'll be hearing a talk from Jay Raj from NVIDIA, who works on NVIDIA AI, and he'll be talking to us about how NVIDIA is working with open source. Other tools on here that are important are Portkey. So Portkey is taking the idea of, Portkey is this, I don't know if you can see my mouse, but can you see my mouse on the screen? I don't know. But Portkey is the hexagon with the, I don't know, bash looking thing, hexagon thing. There's only one hexagon on here, okay? So Portkey is the hexagon looking logo. And what they do is they have taken the idea of an API gateway. So those of you who are familiar with software development, who are familiar with using APIs, who are familiar with API development, you'll know that there's this thing called an API gateway. And an API gateway basically routes all of your requests to the correct API endpoints. So Portkey has taken this idea of an API gateway and has taken it to AI, and they've created this thing called an AI gateway, which can allow you to route different requests to different LLMs and through load balancing and all these kinds of different things. So someone has told me that it's a hexagon plus a chevron. So thank you, Andre. I didn't even know that this was the term for that shape there, but I guess it's chevron. I'm thinking like it's the bracket thing. Okay, I'm getting off topic. Anyway, so other of these infrastructure tools, N8N, right? Viraj came and talked to us about N8N earlier today. N8N is up there. That's the fork looking thing that's in the pink square. Next to them is Lamini. So Lamini is interesting in the sense that from what I can see, Lamini is piloting the kind of expanding of allowing you to run LLMs on other GPUs, right? So one of the reasons why NVIDIA has such dominance in this market is because of CUDA, is because NVIDIA has their own specific language that is very efficient, that is very fast, and works really, really well for LLMs. But beyond that, there's other GPU providers out there that may be able to have similar capabilities. And one of those GPU providers is AMD. And Lamini is able to kind of leverage these AMD GPUs. And one of their plays is allowing you to run LLMs on AMD GPUs. Other than that, there's, of course, the usual suspects, right? You've got Snowflake. You guys should all recognize Snowflake. Down there in the bottom right corner, you got Databricks. So Databricks and Snowflake have this huge rivalry that's like a very it's like one of I don't know, I consider this one of those like classic tech rivalry companies. They both kind of have been around for a while. Databricks came from Spark. They came from the processing kind of like compute kind of angle, and they moved into memory. And Databricks was originally a company that wanted to be an AI company, but they were too early to be an AI company. And now that AI is popular and LLMs are popular, I'm sure the Databricks founders are very happy, and they're like playing quite a big role in AI. And someone mentioned Mosaic earlier, right? So Databricks bought Mosaic last year for like $2 billion, like 6 weeks after they started, which was insane. Or maybe it wasn't 6 weeks, but like they bought Mosaic for like $2 billion. Yes, Coke versus Pepsi. This is exactly how I feel like the tech world feels about Snowflake and Databricks. Beyond that, some of these companies, there's a Confidential Mind. They're a small company. They're out of, I forget which country they're out of, somewhere in Europe. They just raised a small pre-seed round. Pachyderm and Determined AI are on the sides of Confidential Mind. They just got bought by HPE like 3 years ago. They also provide ML pipelines and ML infrastructure like this. Bento ML, Titan ML, they provide you different ways to take your LLM, your pre-built LLMs, and basically put it up and make it accessible. Very, very similar things. Beyond the infrastructure tools, we've got the data tools. So these are, I'm sure that some of you recognize some of these data tools. So please drop me a comment in the chat to let me know which one of these you recognize. So this first data tool here is Pulsar. And really, I don't know if I really should have Pulsar here as an AI data tool. I don't know if they're not specifically geared towards AI. Of course, Pulsar and Kafka, both originally Apache products or projects that do streaming, and they're very popular for streaming. They've been around since before AI, but they do a lot of AI. Oh, apparently I have the wrong logo for DVC. I will fix that. So yeah, please send me the right logo, and I'll get the right logo on there. Earlier we talked about we didn't talk about this. We heard from Xander Matheson from Bytewax, which is this like B thing, the 4 hexagons, the yellow 4 hexagons in the middle. We talked about Bytewax. They do data streaming. Above them is Skyflow, because Skyflow does privacy for data. Earlier we heard from Fabiana about the importance of privacy, and really I should probably have why data on here as well somewhere. The importance of privacy for your data. Let's see, there's, so the V below Kafka, that's visual layer. They do data for computer vision data, basically processing computer vision data. They're very similar to Voxel 51. So thank you, Jennifer. Yes, Voxel 51, unstructured IO, also both in the data tool section. And Voxel 51 will be, or sorry, not Voxel, visual layer, which is very similar to Voxel 51. So Voxel 51, we had Jacob come on and talk about what they were building way back in April, not way back, but 2 months ago, feels like it was very long ago now. We had Jacob from Voxel 51 come and talk about what they're doing back in April. And today we'll actually have a talk from Danny Bixson from Visual Layer to come talk about what they're doing and how you can process gigabytes of huge amounts of video data on your laptop, which is actually quite incredible if you think about the amount of compute that goes into processing vision data. To be able to work on this on your laptop is really quite incredible. Let's see. Beyond that, there's some other interesting ones on here. So there's Proton by Time Plus, which is the weird circles going this way. I have no idea how they came up with this logo because I don't see a Proton in here at all. But they're a streaming platform. They're kind of like Apache, kind of like Pulsar, that kind of deal. And then, of course, earlier we also heard about Flink from Bytewax. And then there's unstructured. Of course, unstructured is surprisingly unique in this space. They're doing something that's not it's not particularly maybe technically hard to do. I don't know. Maybe I hope they don't. I hope no one from unstructured is watching this and saying oh, actually, it's incredibly difficult to do, because it might be. But what they're doing is they're taking different types of unstructured data and they're piping it into, and they're creating pipelines to move unstructured data into your data stores. And there's a bunch of tools that do this. It's not just unstructured, but unstructured kind of does this in a way that nobody else really does. And they have all of this together in one library. And then next to unstructured is Airbyte. They also do data streaming. And I think that pretty much wraps up all of the interesting ones here in the data tool section. So part of how I feel about this section is that really data, like we heard earlier today, data quality, incredibly important, right? Data is going to be what drives the quality of your applications. So these are an incredibly important set of tools, and some of them are data curation, like Voxel and Visual Layer, and or data versioning, like DVC. And some of these are data streaming, like Pulsar or Bytewax or Kafka or Flink or Spark or Proton. And some of these are, other ways to move data around, like unstructured. So there's a bunch of different data tools in here, and I'm thinking about maybe splitting this up. But what you really need to know about this is that these are going to be the tools that are going to be the backbone of your application. Okay, so next up, we've got the vector databases. So we heard today from Frank, who's from Zillis. Zillis maintains Milvis, which is the bird, the blue eye thing. And earlier, someone said Zillis when I was talking about the LLM. So actually, Zillis is on this slide, and it is the black square logo with the 3D. I don't know, plane dimensions kind of thing on it. Next to Zillis is Weaviate. And so we'll be hearing from Weaviate later today. I think they'll actually be speaking right after the break after this. So we'll be hearing from Weaviate later today. And then next to Weaviate is LanceDB. So if you have been following my channel for a while, if you've been following me for a while, you know that I spoke with Chung from LanceDB. He's their founder. And LanceDB is an interesting play in the vector DB space, in the vector space, because they were not initially a vector database. They were a file format, a file type. And what happened is that they basically took the Parquet files, and if you're familiar with Parquet, Parquet allows you fast, I think it's fast columnar access and maybe fast row access. I honestly get my rows and columns mixed up all the time. It's kind of like left and right to me. But I get these mixed up all the time, but they don't allow you fast access to random points, which is what vector DBs actually need. So in vector storage, unlike in regular storage, one of the most important things is the ability to do random access. And so Lance was able to kind of do a good job on that. And so that's why they formed a vector database out of it. Below them is a hippo. So the hippo is Marco. I'm actually not super aware of what they do, but they reached out to me like last month. And so I figured it'd be a good idea to just include this on here as a known vector database. Next to Marco is an eye. No, it's I think it's supposed to be a camera. But that is Aperture Data. So Aperture Data is going to be our last talk of the day today. We're going to be hearing from Vishaka, who is the CEO and founder, one of the founders at Aperture Data. So Aperture has an interesting approach because they're not really a vector. I mean, they are a vector database, but they're also not really a vector database because they're a vector database with a graph store on top of it. So if you remember, if you watched my videos, you'll see that earlier this month I interviewed Jason Koo from Neo4j, and Neo4j is a creating graph database application that was originally made for Java, which is where the 4j comes from. And they're talking about graph RAG, which is one of the most popular, like hip methods of doing RAG. Right, Frank was talking about different RAG things earlier today. There's RAG 1.0, there's RAG 2.0, and there's a bunch of different processes in between. And so Neo4j does this thing called graph RAG, and Aperture Data has gone ahead and created a system that puts a graph on top of your vectors in one system instead of having to use two different types of software to do that. Next to Aperture is Chroma. Chroma is like a embedded vector database. It's kind of like Redis. Redis is below Marco, right? So Redis has been around for a while. They're an embedded database. They're mainly for caching. Chroma, also an embedded database. They may or may not stay that way. They're a very early stage company. Below Chroma is Pinecone. Pinecone is probably, arguably, the most popular vector database. Really great job by James Briggs. He makes a bunch of really good videos. And next to Pinecone is Elasticsearch. This is probably the what I would call the incumbent player in this space. They originally did fuzzy search. They do a bunch of unstructured data kind of search, and then they pivoted into vector search. And then lastly on this corner is Quadrant. Oh, and for you guys, wait, no. This I don't know. Okay, Quadrant is the queue. So yeah, that kind of wraps up the vector databases. Let's go to the next slide, which is orchestration frameworks. So I'm sure that you guys recognize at least two, probably three of these orchestration frameworks. So if you recognize any of these frameworks, drop me a comment in the chat. Let me know which ones you recognize. Okay, so when you're building LLM applications, one of the things you need to do is you need to orchestrate your tools. You need to put them together. You need to pipe data from one to another. You need to connect inputs and outputs. You need to have a way to retrieve data from your vector stores. You need to have a way to do a bunch of these different things. And so there are many, many different ways to do this. You can build your own orchestration tools. You can build your own framework. You actually don't need to use any of these, but these frameworks do make it a lot easier to build these. These frameworks make it a lot easier to get started into the LLM application space. So the most popular orchestration framework is the Parrot and the Link. So if you guys recognize that, drop me a comment, let me know. Next to that is a llama, which earlier, as I was saying, llamas are very, very popular in this space, probably because LLM. And then next to that is a company called, yes, thank you, Jennifer. These are LangChain and Llama Index. These are the two most popular orchestration frameworks in the space right now. Next, that is a company called Boundary. So what they do is they basically, if you think about TypeScript and JavaScript, if you're familiar with these, JavaScript or TypeScript was JavaScript with enforced typing. And so that's kind of what Boundary ML is like for LLMs. They kind of enforce a type of output. Below Boundary is a company called Microsoft, a very small company out of Red. No, I'm just kidding. But Semantic Kernel is a not a huge project at Microsoft. Semantic Kernel is their kind of like LangChain play. Yes, someone else recognizes LangChain as well. BML is cool. BAML, I assume you're talking about Boundary. Yeah, it's a pretty cool language. It's really hard. I mean, like I thought it was really hard to get started with. I know they've been doing a lot of work on it. It's been getting a lot better, but it is very cool. Let's see. Also in here is Haystack by DeepSet, which is right below LangChain. That's the green one with the H and the loop around it. So Haystack is interesting in the sense that they did not originally start as in the LLM space. So Haystack was originally an NLP pipeline for enterprise use cases. So they have an interesting kind of like niche or area in here. So they help you with NLP stuff, and they're very enterprise heavy. So they have a lot of enterprise ready features, very good for bigger kind of projects. Then there's also Flight. Flight is by Union AI. They're also based out of Seattle. And they came out of Lyft. So Lyft needed a way to orchestrate some of their LLM, not LLM tools, ML tools, actually, nothing to do with LLMs. And they spun out Flight as an open source framework, which then developed eventually into a company. On this other side here, on your left-hand side, probably is maybe your right-hand side, is GripTape, which is a small company that does something very similar to LangChain. And then under that is DSPy. And so we'll actually be hearing more about DSPy in a few minutes when the Weaviate people come, because I'm not entirely sure if we'll be hearing about DSPy from Weaviate, but I have been seeing them do a lot of events together. And one of their developer advocates has been talking a lot about DSPy on Twitter. And in fact, I pretty much only heard of this framework because one of their developer advocates was talking about it so much on Twitter that I was like, okay, I'll go take a look. Okay. So DSPy is a orchestration framework that I'm sure that I would bet that the Weaviate people will talk more about later on, and I will let them talk to you about it because I don't know that much about it. Next is the quality tuning stuff. So this is really, really important for basically production, right? When you're putting things into production, you need to ensure that they're high quality. And we heard from Honeyhive, which is this like 3 set of hexagons earlier today. They were the first talk today, right? We heard from Mohawk from Honeyhive. He gave a talk about LLM quality tuning and ensuring that your LLMs are high quality in production. And later on today, we'll be hearing from Aparna from Arise. Arise is the, I guess, is that also a chevron? I guess it's also a chevron with a dot, the chevron dot. That's Arise. Next, that is Truera. So Truera is a company that they created this product called TrueLens. They came out with this kind of like triad for RAG quality. And they actually got acquired by Snowflake. So maybe I should just have Snowflake in the quality tuning area. But as far as I understand, they're still kind of operating independently. Some of these other tools here include like, YLabs. So YLabs is a tool that's much like Honeyhive, much like Arise. They kind of tell you like their observability monitoring. They tell you why things are, going wrong if they are in your data and things like that. Many of these other companies are quite a bit smaller. And the reason for that is just because quality tuning is something that's quite new and quite, it's not like quality tuning, the concept isn't new, but like in terms of LLMs are in such an early stage of development. The technology is just in such an early stage of development that a lot of the quality tuning stuff is not super developed. And so a lot of these companies are out here developing some of these things. So actually like Arise and YLabs and Truera and Aporia, which is next to Truera, and Honeyhive, these actually all came out of the ML ops craze from 2018 to 2022. and they've just recently kind of developed or turned into these LLM OS-based companies. Okay, let's take a look at the next slide. So these are some QR codes that you can scan that will take you to some code samples. This pretty much wraps up my covering of these tools. I hope that this kind of set of this kind of introduction to a bunch of these tools was helpful for you in the sense that it allows you to understand this kind of framework in a better manner, right? So I gave 8 different sets of tools for you to think about, with the possibility of thinking about data processing or data tools as a completely as one entity, or as split out into 3 different entities. So there's a bunch of different ways that you can think about this, but I hope that this was a good way for you to start thinking about how you can build LLM applications with LLMs, LLM providers, quality tuning tools, vector databases, embedding models, and all sorts of other tools that will help you build large language model applications. And this set of QR codes here, this will take you to 2 different repos on GitHub, where you can figure out how to build, where you can just find some code and figure out how to build some of these AI applications from scratch. This is like a proof of concept kind of thing. This is not really going to build something for you in production, but this will help you get into proof of concepts to build different LLM tools. I only have a couple more slides left here, so I will round out probably just at the time that I predicted. So these other 2 QR codes are for those of you who want to keep up with more events. You can scan that code. It'll take you to our calendar, to the OSS for AI calendar, and you can use that to keep up with more events. And then next to that will be jobs. So if you are interested in jobs in AI, if you're interested in jobs in open source, we do kind of keep sending out these emails to get people into different jobs and things like that. And I believe that's actually it. Oh, keep up with me. Aha, I forgot. This is the most important slide, of course. Yes. You gotta, if you want, if you want to keep up with me, scan this QR code here. This QR code here will take you to my LinkedIn, and you can kind of keep up with all the things that I post on LinkedIn, which is some insights into LLMs, some of the things that I care about. For example, how I think cosine similarity is a stupid similarity metric, and how a paper that came out earlier this April really vindicated my belief of this, and some other things as well. Thank you, Jennifer, for the kind words. So at 10:20 exactly, I've wrapped up my talk.